This video is over chapter 52, polar curves and arc length. So we're going to look at example 281, where our polar curve is r is e to the theta. Theta ranges from 0 to 2 pi. So when theta is 0, r is 1. When theta is 2 pi, r is e to the 2 pi. And I've given the rectangular coordinates here. So when theta is pi over 2, r is e to the pi over 2, so that's here on the y-axis. When theta is pi, r is e to the pi. But the point e to the pi is right here, and in rectangular coordinates our x-coordinate is negative. And similar right here, our y-coordinate is negative. The r's are positive, but the x, this x and this y is negative. And so we want to find the arc length, so we just integrate over the length over our interval 0 to 2 pi of r squared plus dr d theta squared under the square root. So since r is e to the theta, well, dr d theta is also e to the theta. So when we integrate, we have r squared, so e to the theta squared, plus dr d theta squared, so e to the theta squared. Add these together, so we have 2e to the 2 theta, square root of 2, so 2 comes out of the square root. We have e to the 2 theta under the square root is just e to the theta, so the square root of e to the 2 theta is e to the theta. So now we just have an exponential function times a constant that we're going to integrate. Finding an antiderivative is not very difficult. Substitute in our limits of integration and subtract. So we have square root of 2 times e to the 2 pi minus e to the 0.